Hi everyone, this is 12.7. We're going to talk about parallel lines and transversals, and we're going to keep talking about proofs, which we've been working on for pretty much all of Module 12. So first of all, let's start with the easy one. We know what parallel lines are. Parallel lines are any two lines that never cross. Even if you extend them forever, they're like right next to each other like train tracks. They keep going forever, they never cross each other. So instead, let's focus on notation. When you see that symbol you see right there where it's two vertical lines, those are actually two parallel lines. That's the symbol for is parallel to. Or what we can do is we can actually draw it on the picture. So number one, right here, this is the symbol I was talking about. That symbol says line AB is parallel to line CD. If I didn't want to actually write it out though like that, what I could do is I could put these little arrow markers on the lines. And I'm not talking about the arrows on the ends. All lines have arrows on the ends that show they keep going forever in two directions. I'm talking about having these arrow markers in the middle, these little triangles we draw on them to show that those two lines are parallel. Either one is fine. You can draw it on the picture or you can write it using a little math statement and that parallel symbol. Either way, that means the lines are parallel. Okay, so the other vocab word straight from the title of the section was transversal, and this one probably is new to you. To transverse something means to cross. So a transversal is a line that crosses other lines. It's got to be two or more. But what we're going to focus on today is when a transversal crosses two parallel lines, it creates groups of special angle pairs, and we want to make sure we know those. So right here, what we have is a picture. We have two lines that, well, actually right now I would say these two lines look parallel. If I wanted to make sure that they were parallel, I would draw the little arrows on them that we just talked about like this. So now those little red triangles or arrows that I drew on them show that those lines are parallel. So now we have two parallel lines and then a transversal, one line, one diagonal line crossing over them. And it actually creates 8 different angles. I numbered them 1 through 8 so we can talk about them. And our first vocab word for angle pairs is corresponding angles. So I said, what you want to do is notice that you have two groups of 4 angles. You have this group up here, 1, 2, 3, and 4. And you have this group here, 5, 6, 7, 8. It's actually two copies of the same pairs of angles. Like if you imagine, if this was on paper instead of on my computer screen, and I cut out that circle around angles 5, 6, 7, 8, and then moved it up and put it on top of angles 1, 2, 3, and 4, the angles that match up are corresponding angles. So for the notes, I said, okay, one example of corresponding angles is angle 1 and angle 5. But 2 and 6 are also corresponding angles, 3 and 7 are corresponding angles, and 4 and 8 are corresponding angles. So corresponding means they correspond to each other. So like the best example is what I said first. Cut out that circle of 4 angles, put it on top of the other 4, which ones match up? Those two are what we call corresponding angles. Okay, now the rest of our vocab terms has to do with understanding certain words. So what we have right here is alternate interior angles. Now, alternate and interior, each word means one thing. Come on. There it is. Okay. So first of all, let's start with the second word, interior. You have two parallel lines. The interior is in between those two lines. That's what interior means. It means in between. Now, the exterior is outside of the line. So up here is exterior, and down here is also exterior. So interior and exterior have to do with your parallel lines. Interior means it's in between the lines, and exterior means it's on the outside of them. Now, the word alternate, to alternate means to switch back and forth. So alternating has to do with the transversal. Alternating means one from each side of the transversal. So, let's clear all this out. Alternate interior angles, the examples I gave you would be 3 and 6. Interior, because they're both in between the two parallel lines. alternate because they're alternating sides of the transversal. Now the other example that would work for those, even though I didn't type it up, I just gave you one example of each for the notes. The other one that works for that is 4 and 5. So 3 and 6 are alternate interior, and so are 4 and 5. Okay, then it kind of went out of order here, but I'll go in order. Then we do alternate exterior angles. Now we already talked about what exterior means. Exterior means, like for this picture, the top and bottom. It means on the outside of the parallel lines. And alternating means one from each side again. So I could take 1 and 8, that would be alternate exterior angles. Or your other possibility would be 2 and 7. Those are your two different pairs of alternate exterior angles. Exterior because they are outside of the parallel lines, but they're still alternate. There's still one from each side. And then the last one, the consecutive interior, that one came up a little early. I didn't mean for it to, but that's okay. Consecutive interior angles, we're back on the interior, back on the inside, but consecutive means in a row. So those are consecutive, and those are consecutive. 3 and 5 are consecutive interior, 4 and 6 are consecutive interior. So those are all the vocab words. Here's a quick summary for you, because instead of trying to memorize like what does alternate exterior mean or what does alternate interior mean, think of the words separately. So I told you guys the transversal is the first word. Alternate means one from each side of the transversal. Consecutive means both are on the same side of the transversal. Then the second word has to do with the parallel lines. Interior means in between the lines, and exterior means outside of the lines. And as long as you know what each word means separately, like when you think of alternate interior angles, that sounds very long and confusing. But when you say, okay, what does alternate mean? What does interior mean? It makes it very simple. Okay, so here's our first math rule for this section. It's a postulate. And remember, we said postulates and theorems are both math rules. In the long run, they're both basically the same thing. Postulates are usually a little bit more simple. Theorems can be more complicated. But our first postulate for today says, if a transversal crosses two parallel lines, all pairs of corresponding angles are congruent. So that's what I said earlier, right? When we were first looking at that picture, and I said, you have those angles, 1, 2, 3, 4, and then you have another group of angles, 5, 6, 7, 8, and it's like a copy of the other one. If you cut out one of them and put it on top of the other, it's a perfect match. That's because the corresponding angles are congruent. Angle 1 is congruent to angle 5. Those two match up, they're the same. 2 and 6, or whatever the numbers are. As they match up, each angle that matches up with its corresponding angle will be exactly the same, a perfect copy. So now let's do a proof. Let's actually take what we just learned. We're going to use that postulate we just learned. We're going to take a picture very similar to the one that we talked about earlier with those 8 angles. And we are going to prove that angle 1 is congruent to angle 8. So let's set up a proof. Let's do a 2-column proof with statements and reasons. And for every proof, remember, one thing's automatic. The first thing you do is you take whatever was given in the question. That would be that n is parallel to m, and your reason is given. Okay, that's an automatic. And what I'm going to do, I like to mark my picture. So we just said those two are parallel. I'm going to mark it in my picture. Now let's make a plan. What we're trying to prove is that angle 1 is congruent to angle 8. Now, 1 and 8 are not corresponding angles, and that's the only postulate we have so far. 1 and 5 are corresponding angles. So here's my plan. I like to come up with a plan first before I write anything down, before I just start, saying step, 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 step. I like to have a plan. If I look at my picture, I could say that 1 and 5 are congruent because they're corresponding angles. We just learned that. Then I could say 5 and 8 are congruent because they are vertical angles. We learned that a couple modules ago. Now if 1 is the same as 5 and 5 is the same as 8, then 1 is the same as 8. That's the transitive property, which we talked about, and I told you was a real important one. You guys are going to use it a lot. So I think I have my plan. Let's do those steps. For step 2, I'm going to say angle 1 is congruent to angle 5. And my reason is those are corresponding angles. Remember, I'll mark it in my picture right now so you can see. What I'm saying is that angle 1 is congruent to angle 5, those two right there. Now the reason for that is the corresponding angle postulate. And remember, two things. Number one, I like to abbreviate. Instead of writing out the word angle, I might just do the angle symbol. And instead of writing out the word postulate, I might do POST period. It's okay to abbreviate. And it's okay to also not remember the exact name. Basically, in this situation, for your reason, if you say anything at all about corresponding angles, so I knew that you knew that's why they were congruent, you get credit for that. Okay, the next step in my process was to say that angle 5 is congruent to angle 8. And if I mark that in my picture, see, 5 is already marked, so let's just give 8 the same mark. And we said we know those are congruent because they're vertical angles. Now same thing, vertical angle, I'm going to use the angle symbol. Now technically it's the vertical angle theorem. I do THM for theorem. But if you say anything at all about vertical angles, you get credit for that. So now if you look at your picture, we can see 1, 5, and 8 are all congruent to each other. 1 is congruent to 5, 5 is congruent to 8, they're basically all the same. That's the transitive property. So I'm ready to say angle 1 is congruent to angle 8. The reason is the transitive property, which says that if two things are congruent to the same third thing, then all three of them are the same. So if angle 5 is congruent to both angle 1 and angle 8, then angle 1 and 8 are the same thing. They're also congruent. And we can tell we're done because, remember, in a proof, you're done when what you see here is exactly what you see. It has to be exactly the same thing. And it is. I started with the given. I got from given to what I was trying to prove, and I gave a reason every step of the way. That's what a proof is. Okay, so what we actually did, let's see here, let's erase some of that so you can read this. I made a note here. I said what you guys actually just did is you proved the alternate exterior angles theorem. You proved that alternate exterior angles are congruent. Because that's what we did. We proved that angle 1 is congruent to angle 8. If you look back at the picture, angle 1 and angle 8 are alternate exterior angles. So we proved that if n and m are parallel, then 1 is congruent to 8. By doing that, we've proven that all alternate exterior angles are congruent. And that's how theorems work. That's how proofs work. When you prove a new theorem, you're not just doing a math problem, you're making a new rule that you can use later. So from now on in all of our proofs for the rest of class, if you ever wanted to, if you have this picture right here, and you ever wanted to say that angle 1 is congruent to angle 8, you don't have to go through that whole proof anymore. From now on, you can say angle 1 is congruent to angle 8 because exterior angles are congruent, or by the exterior angle theorem. So that's a new theorem for us, and that's what we're going to be doing throughout the rest of the semester, is we're going to be doing new proofs. And each proof you do, you can use in your next proof. All right, so I'm not going to do the work for it, but we could also do a very similar proof that would end up showing that alternate interior angles are congruent. And we could do a proof that shows consecutive interior angles are not congruent, but supplementary, meaning they add up to 180. So right at the beginning of notes today, I said, we're learning special angle pairs for this situation where you have two parallel lines and a transversal. The special pairs are, number 1, corresponding angles, they're congruent. Number 2, alternate interior angles, they're congruent. Number 3, alternate exterior angles, they're congruent. All three of those are congruent. The only one that's different is the consecutive interior angles. They're not congruent, they're supplementary, which means they add up to 180. And the last thing I want to add real quick, this is the end. Each of these theorems is actually a biconditional statement. It's an if and only if. So these are the theorems that work both forwards and backwards. So for example, our first postulate said, if the lines are parallel, then corresponding angles are congruent. Well, you can work that backwards. You can say, if the corresponding angles are congruent, then the lines are parallel. So in one question, you might know the lines are parallel and be asked to prove that the angles are congruent. In another question, the given might be that the angles are congruent and you're asked to prove that the lines are parallel. But it's the same theorems and all of them work. So look at the ones on the screen right now. If the alternate interior angles are congruent, then the lines are parallel. Works forwards or backwards. Same with the second one. If consecutive interior angles are supplementary, then the lines are parallel. So each of these four theorems works both forwards and backwards. Or I guess four theorems plus one postulate, because it works for corresponding too.